Hello everyone. So today I'm going to show you how to code in an object-oriented way in Python. So first of all, what is object-oriented programming? Object-oriented programming is a way in which we bundle all the variables and related methods in one class so that we can use it easily in the whole program, and it is very extensible. So what are the pillars of object-oriented programming? There are four pillars of object-oriented programming. The first one is inheritance, the second one is abstraction, the third one is encapsulation, and the fourth is polymorphism. So let me explain this one by one. Let us create a class named as person. So we create a class by writing the class keyword and then writing the name of the class that we want to assign to it. And then if we want to pass any parameters, we need to have the init method. So we write it by using init, and then first of all we have to pass a default argument named as self. So we pass the first parameter named as self, the second and the rest of the parameters are defined by us. So first of all, let me pass the name parameter. So a person is going to have a name and it is going to have an age. So I've passed the age parameter also. Next I want to store these variables in my object. So for storing these variables I need to write self dot name equals to name. So I'm storing this uh, name variable in the name variable of the person. So whatever value this name is gonna get over here as an argument is gonna get passed over self dot is gonna get assigned to self dot name, and so then we can use this anywhere inside our methods which we are going to define in the person class. So let us define another variable named as age. So this is the age variable. So we have completed the person object. Now we need to define some methods such as speak. Let us say the person speaks something, so we want to just print out my name is, and let me convert this to f string so that we can use variables easily. Self dot name. So we reference whatever. So first of all we need to write self over here. If we forget to pass self, then we won't be able to access the uh, variables that this object has. So we have passed self, and then now we are able to access this name variable of the class. So we are going to print now my name is self dot name and age is self dot age. So we have defined a class person. So now let's test this class by creating an instance of this object. So I have stored the instance of the person class in a person variable. So let me pass the parameters that we need to. It has a name and an age. So first let me pass name as John and age as let's say 19, and we want this person to speak. So we can call this method by writing person and that we add a period, and then we add the name of the method that we have defined. So name is speak, and then we add the brackets to call this function. Okay, so now let's test this code once. Okay, so you can see that it has printed my name is John and age is 19, just as we did over here. So now let us say we want to have another class named as teacher. Okay, so we have created the class teacher. Now we now think let us think that teacher is also a person, right? Teacher is also a person. So we want to inherit all the methods that the person has into the teacher class that we have created. So to inherit all the methods, we just type the name of the parent class in the brackets over here. So we write person, and so this is referencing that teacher is the children and child, and person is the parent class of this child. So next we want to initialize this class by typing init. Okay, so it has the snippet already created the class for me, but I want to do it manually. So let us write self and name age, because we want to pass all these two arguments to the parent class. So we are typing name and age parameter right over here. After that we are going to type super dot init to initialize the parent class, and then pass whatever parameters we have defined. So we are going to pass name and age. Okay, so we have initialized the parent class. Now it has inherited all the methods that this person was going to have. And so let us say we want to have another property named as subject. So which subject the teacher teaches, and let us store this in a variable named as subject. Okay, so we have created a variable subject. Now let us say we want to add a method named as teach, and we want to pass self over here because we want to access the subject variable of this class. So let us now print teaching, and we want to convert it to a string self dot subject. So now let's comment this out and create a teacher object by typing teacher and then typing the name of the class, which is teacher, and these are the parameters that we want to pass now: the name, age and subject. So let us say the name is Jake, age is 34 years, and the subject is physics. Okay, so we have initiated a class and created an instance of it. I've created an instance of teacher class. So next I want to call a method named as teach from this class. So I'll write teacher dot teach. Okay, so now let's look at the output. See, it is saying teaching physics. Because we passed the subject as physics, this string is going to get stored into the subject variable over here, so in self dot subject, and after calling this teach method, it will print teaching self dot subject. So it is referencing this variable from the variable that we defined over here. So we have also inherited the person, the objects of person class. Sorry, we have inherited the methods and variables of person class. So let us call teacher dot speak and comment this teach line because we no longer need it. So now let us run this code and see, it is saying my name is Jake and age is 34. So we have inherited whatever objects and variables, the whatever methods and variables the person class had, and assigned it to the teacher variable. So this is very extensible. Suppose we want to have another object named as student. So we create a class named as student and then inherit from the person object. So to initialize this class, we write init self name age. To pass it to the parent class, we type super dot init and name age are the parameters. Now we want to have another variable named as standard to define in which standard the student is studying. So we write standard over here. We don't write standard, sorry. Okay, so to store it in a variable, we write self.standard equals to standard. Now let us say that this student object is going to speak something again, but we don't want it to behave as the same as the person behaved, such as it printed my name is self.name and age is self.age, but we don't want this. So there's a concept known as method overriding, in which we define a method in the child class, and if the name of the method is same as the parent class, then the method gets overridden, so the behavior changes. So let us say def speak, and we want to pass self over here, and we want to print out that my name is self dot name. We want to convert it to f string, and I study in standard, and pass the standard over here, self dot standard. Okay, so we have created the speak method of the student, but we also notice that the speak method is also present in the person class, which is the parent class. So because the name of this method is same as the parent class, so the method gets overridden and the behavior is now going to be the same as defined in the student class. So let us comment this out first and create a student object by calling the student class, and then we want to pass name as J, age as 12, and the standard is suppose 6, and then we want to call a method named as speak. So it is going to print this line. So now let us see what it prints. Does it print this statement or does it print this? So let us run this code once. Okay, so it is printing my name is J and I study in standard 6. So you can see that the method that we defined over here is overriding the method of the parent class which was defined over here. So this is method overriding, which is sometimes useful, but it is not a best practice to override any method that is defined in the built-in modules, because we don't want our application to get crashed every now and then. So the example we saw here in student and person was an example of polymorphism. So polymorphism means many forms. So this speak method over here has many forms. One form is defined in the person parent class, and the other form is defined over here in the student, which is the child class. So this is polymorphism. We can also have a speak method in teacher class which behaves differently as the student. So that's why the name given to this is polymorphism, because it has many forms. So next we want to know what is abstraction. Okay, so first let me suppose that we want to have a voting system, and we want to have a function which decides whether the person is eligible to vote or not. So let us define a method in the person class such as calculate eligibility, and we want this method to be private, but there is no concept like private methods in Python. So we added two underscores to define that this method is private and should not be changed, so as to keep the functionality intact. So first of all, let us write change decide eligibility. So this is a private method that we have defined. Now let us write self so that we can access the variables over here. Then we write if self dot name, sorry, self dot age is greater than equal to 18, then return you are eligible to vote. Now if this condition is not true, then this line is going to get skipped, so we are directly gonna return you are not eligible to vote. Okay, so instead of you, let us type name, so self dot name, and write is write self dot name over here also. Okay, so we have defined a method known as decide eligibility, and this is a private method. Nobody is going to access it because we have defined it using two underscores. Actually we can access it, but it is a good practice to write two underscores so that the other programmers know that this is a private method and should not be changed. So let us create another function to get eligibility. Okay, so let us call this function self dot decide eligibility. Okay, so instead of returning this, let us suppose we want to move this piece of code to this statement, and we want to return true over here and return false over here. Okay, so now we write a condition if self dot decide eligibility, so it is going to have the boolean values. Then we are going to return or print. Let us print this out. Okay, so we are going to print this out on these conditions. So now let me call this, and this piece of logic is completely abstracted from the other methods, so we are not going to access this piece of method. It is a private method. We will be able to access it, but we won't, because there we have defined it as private. Okay, so now let us say student dot, see, you can see that we have two underscores and the name of this method, but we will not be accessing it. So now let us access the eligibility by get eligibility. So we have abstracted this whole logic and implemented it into this method known as get eligibility, so that this is accessible, so only the final output is accessible to the user, not the implementation. So the whole implementation resides over here in decide eligibility, and the uh, output is we are going to get over here. Okay, so we have typed get eligibility over here. Let us also fetch the eligibility of the teacher to vote. So let us write teacher dot get eligibility. So now let us run this code once. Okay, so you can see that it is printing Jake is eligible to vote. Okay, there's a bug in our code. Actually we should return from here so that it doesn't get executed further. So let us run this once again. Okay, So here we had declared Jake as the teacher, so he is eligible to vote because he is 34 years old, which is greater than 18, and J is not eligible to vote because he is less than 18 years, because so that uh, so he is not eligible to vote. So this was abstraction in action. All the implementation of decide eligibility was abstracted from the user, and then it was put in a private method, and then we access the private method inside of our inside of the method that we want the user to use. Okay, so what are the merits of object oriented programming? So in future, suppose a programmer wants to add another method having some additional functionality, so we can add it just by typing def, and then let us say a person wants to walk, so we can add walk, type self, and then for just now we want to print walk. Okay, so we've added a method in the parent class, and this method also gets added to the children class automatically. We don't need to manually type this method in every class, in each and every object, by our hand. So let us quickly recap what we learned today. So first of all, we learned inheritance. We created a class person, then created a class teacher, and then and then student. And the teacher and student class is inherited from the person class. So this was inheritance. Next, we looked at abstraction. So what is abstraction? We hid the details of this decide eligibility into a private method, and then called it inside a public method, so that the only the output is visible to the user. Next, we looked at encapsulation. We bundled all the data and its related variables into a single class, such as class person, then class teacher, and class student. Then we looked at polymorphism. We looked at this speak function in the parent class person and the speak function in the child class student, and saw that both of them have different forms, have different functionality. So these were the four pillars of object oriented programming. I hope you have learned all these concepts very well, and be sure to like and subscribe if you like this video and have learned something new about Python. Thank you very much.